Okay everyone, this is the start of Unit 2, our hydrocarbons topic. Here's our first lesson. It's going to be on alkanes. This should be revision from S3, so hopefully you get through this nice and quick. So learning intention is you're going to learn or relearn the first 8 members of the alkane family. And by the end of this lesson you should be able to write molecular and structural formulas for all 8 of them. And we'll be doing some uses and some other properties of alkanes as well. So, hydrocarbons. All hydrocarbons are fuels and they all have something in common. So we're going to look at the first family of hydrocarbons, which is alkanes, which starts with methane, ethane and propane. You'll see methane has 1 carbon, ethane has 2 carbons, propane has 3. You will need to know the first 8 members of the alkane family. So all fuels are made of hydrocarbons. And what do we mean by hydrocarbons? Hydrocarbons are a set of substances which only contain what and what. So even if you pause this video just now and try and answer that in your own time and then restart the video. So hydrocarbons are a set of substances which contain carbon and hydrogen only. So hydrogen and carbon is in the name. Next, they can all be divided up into families. So the first family that we are looking at is the alkane family. And another name that we give these families are known as homologous series. So the first homologous series is going to be alkanes, and then we'll move on to alkenes next time. So members of the same family, so all alkanes have similar structures, and we'll go over what that structure is, and they also have similar properties, so similar structures and properties. Right, so the first family is the homologous series as alkanes. It starts with methane, ethane and propane. So if you go to your OneNote, you'll be able to see a similar table to this, and I just want you to go through this table, rewrite it in your jotters, and I want you to do the molecular formula, the structural formula, how many carbons and how many hydrogens it has, and just work through that in your own time. Now, the difference between structural formula and molecular formula we will look at on the next slide. So, molecular formula, this column here, molecular formula is how many atoms of each element are present. And an example of that is C2H6, which is ethane. The full structural formula is where each atom is found. So again, here's ethane, C2H6. Remember, carbon is in group 4, so it can make 4 bonds. Hydrogen is in group 1, so can only make 1 bond. That's a good double check at the end, make sure each carbon has 4 bonds around it, and the hydrogen can only make 1. So that is the full structural formula of ethane. And again, you can work through that table in your OneNote. So a lot of these slides will have some of the answers, but what I'd ideally like you to do is just go through the table on OneNote on your own. Just looking at these examples, you will need to know all the way up to octane. So for instance, hexane, you should know a hexagon has 6 sides, therefore it has 6 carbons. An octagon or octane has a shape that has 8 sides, so therefore it has 8 carbons. And then finally, can you think up a rule? So if you have 8 carbons, how do we get to 18? So again, pause this video and have a think of the rule, what might be. And the rule is CnH2n. So no matter how many number of carbons you have, all you need to do is times that number by 2 and then add 2 on. So for instance, if we had carbon 500, to work out how many hydrogens it has, you would need to times that number by 2 and then add 2 on. So that would be 1002. Likewise, you could work back the way. So if we had 2002 hydrogens, we'd need to take away 2 first and then divide by 2. So if we had a alkane that had 2002 hydrogens, you take away 2, you get to 2000, and then you half it, so it would have 1000 carbons. So you can start with hydrogens or start with carbons, you can still work out how many. Okay. Right, this slide, we don't really need to know the order. Why not? Because if you go to your data booklet and you go to page 9, so this page here, it gives you methane, ethane, propane, butane, pentane, hexane, heptane and octane. And you'll be able to see from this slide, as you go from methane to octane, the melting point increases, as does the boiling point. So you don't need to actually remember the order, it is all there in the data booklet. So that slide we don't really need to know. So some properties, as we've looked at the data booklet, as you go from methane to octane, the melting point increases and so does the boiling point increase. So methane has the lowest boiling point. What about volatility? So methane that comes out the gas tap in the lab, that's very, very volatile. And as you go down from methane to octane, they get less volatile. So last slide I think this is. So what I would do is just remember at least one alkane and a use for that alkane. So methane, we all know, there's a picture of a cow here because cows fart out methane. Methane's also used in cooking and central heating. It's the gas that comes out the gas tap in the lab. Also propane and butane are still gases. They are used in caravans and camping gases. You may have seen these canisters before outside a caravan. And the final one we can look at is octane. Octane is used in petrol. And if you ever go to the petrol station and on this little flap here on the pumps, you will see it has an octane number on there, so we know that there's octane in petrol. Okay, so that's the end of the slide. So if we just go to OneNote, go to your designated OneNote, you've got your learning intentions and success criteria. Just make sure that you can do everything in all of these success criteria before you move on to alkenes. We have the lesson here. This is where the video is that you're watching right now. That'll be in here. So there's a nice starter task in there for you. What is the definition of a hydrocarbon? Just write your answer in that text box there. And then I want you to go into this table, complete that table as we discussed earlier. I've tried to make the boxes as big as possible. Just try and draw it to the best of your capability as you can. So we know the top one is methane. It has 1 carbon, 4 hydrogen. Its molecular formula is CH4, and its structural formula looks like that. So if you can just fill that table in. Once you've done that, move on to task 2, which is just a list of 9 questions. All the answers should be in the PowerPoint. work through them. And then in task 3, these are more consolidation problem solving questions, and I want you to answer all 3 of those questions, and that is lesson 1 on revision of alkanes. Good luck.